Hello, everyone. Welcome. We'll give it a few seconds as people are joining, but so glad everyone is here. All right, let's get started. Welcome to the deep dive into the new vast capabilities. I'm going to go ahead and introduce our speakers. Today, we have Howard Marks, who's extraordinary and plenipotentiary of vast data. Howard he is so knowledgeable on all things vast. So thank you, Howard, for being here. He'll be joined later by Jason Ressler. Jason is Technical Director of Alliances at Vast Data, so thank you as well, Jason, for being here. Just a little bit of updates for you all. You can ask your questions today using the Q&A tab on the panel on the right-hand side of your screen. You can also ask them anonymously just by clicking the Hide Your Name checkbox at the bottom of that panel. We will try to get to your questions at the end of today's webinar, but if we run out of time, we will pull those questions and follow up with you all directly. So don't be afraid to ask those questions. We love all of the engagement. Right now, I'm going to invite Howard to come on stage with me, and we will get started.
Thank you, Analia. So as we produce updates to the VAST operating system roughly quarterly, I decided to get a little Shakespearean with today's title. And so it is "Begone midwinter of our discontent, made glorious summer by vast updates." Being an American, I'm not all that much in favor of the Prince of York, so it fits pretty well. See, we saw that slide already. So the next release of the VAST software, which should be out in a few weeks, is version 5.3. And we've, as usual, have made some significant updates across the entire data platform. The two big stories are additional protocols. VAST, before we added support for structured data and databases, we called the VAST data platform universal storage. And now we're making it truly universal storage, expanding into those use cases where customers prefer to use block I/O instead of file or object I/O. So we are adding block support. We're also adding support for we've built in an event broker, a system to manage messages between services within your data center that is compatible with the Kafka APIs. And Kafka is the most commonly used event broker. And so this will allow you to build event brokers and workflows within the VAST data platform much simpler than with the open source alternatives. We make periodic updates in terms of security and multi-tenancy. In this case, we're extending multi-tenancy to include per-tenant management and dashboards. We're extending multi-tenancy to the VAST database. Previously, the default tenant owned all databases, and now the tenants can own databases just like tenants can own views to other sorts of data. Many of our customers in HPC and AI use job schedulers rather than having users directly perform work on the system. And that means that they would like visibility into not only which user at which station or on which server is occupying the system and creating a lot of I/O, but which job were they running so that we can narrow down what's creating that hotspot and why that neighbor is being noisy. And so we've added that functionality to the system. Across the VAST data space, we are extending the use of the global namespace with S3 access in addition to the previous file access. We're extending NFS NLM locks across the global namespace, so users can modify the same file at the same time from completely different locations, and we'll still maintain the locking semantics of their application so that they can control who has access to what part of that file at any given time. And then Jason will go into some more details about the updates on the database side, but those include some improvements in our built-in query engine, general improvements in performance, and improvements in visibility. So let's talk a bit about block protocols. With version 5.3, we've added support for NVMe over TCP. NVMe over TCP is the modern replacement for iSCSI. It carries NVMe messages instead of SCSI messages over standard TCP IP, and that means that it doesn't require any special network preparation. And this is the protocol that our customers are telling us they're most interested in. If we hear customer demand, we'll add support for iSCSI as well. But all of this is to support the concept of accessing a shared data platform like VAST through the metaphor of virtual SSDs, which we typically call volumes, or for historic reasons, LUNs, which is short for logical unit number and relates back to old SCSI stuff. This means that a server has a software initiator that sends NVMe over TCP messages to a subsystem, a logical array. And those requests are to read fixed size, either 512 byte or 4K blocks. It's NVMe over fabrics with TCP IP as the transport or the fabric. Should we see sufficient demand, we can, of course, add NVMe over RDMA, which we use internally, but that requires more network preparation, and so TCP was more appropriate for the first instantiation. One of the big advantages of block protocols is that they're inherently multipath. File and object protocols were really designed for users, clients, to be accessing servers. Block protocols are designed for host servers to be accessing storage, and that requires a higher amount of bandwidth that you get from multipath, but also the higher resilience that multipath gives you, so that the loss of a network link doesn't disconnect a server from its storage. There are NVMe over TCP initiators in the Linux kernel since 2019, so any modern version of Linux. It's been in vSphere since version 7, so that's the past couple of years. If you're updating your software at all, you shouldn't have any trouble. Windows users, it's in the latest version of Windows Server 2025. So how does VAST do block? Well, we implement in the VAST data store or the VAST element store a protocol-independent universal data store. And we then implement protocol modules to translate between a given access protocol and the element store. Block IO, specifically NVMe over TCP, is just another protocol module. It is a peer protocol with NFS, SMB, and S3. A volume is a new type of element. Previously, we supported an element type for files and objects, and tables are an element. And now a volume is a new type of element that's addressed by logical block addresses. Each volume is stored in a unique folder so that we can apply the data services that we provide to folders in the VAST data store: snapshots, replication, quality of in-service, encryption, and so forth, to that volume, because that volume is going to be contained in that folder. Access is managed via views. So you create a view that uses a VIP pool that is a set of virtual IP addresses on some set of the C nodes in your cluster. The view policy controls what hosts have access. And the other thing that you need to know is, because of the way VAST does snapshots based on timestamps in metadata updates, all snapshots that are taken at the same time are consistent without needing to create explicit consistency groups. So if you have a cluster of servers and you want to take a snapshot on all of them at exactly the same time, all you have to do is declare those to be exactly the same time. Why block on VAST? We've been offering file and object. Almost every app workload can do that. Well, the most difficult part to do through file and object is boot. Pixie boot, it does exist, but it's unwieldy and no one really wants to do that at scale. But boot from SAN is built into the UEFI BIOS in modern servers. So you can configure servers to boot from volumes on a shared storage system. And that means when it's time to update your 50 or 500 GPU hosts to a new version of their operating system, you can create one golden image, boot your GPU server from it in testing directly, and then clone it to create 1,000 images to boot 1,000 hosts from. The other major use case are persistent volumes for virtual machines and containers. Hypervisors and container environments will use files for persistent volumes, but it's an anti-pattern. Most customers are more comfortable doing those things with block. Part of that is the built-in multipath capability so that one host can be connected over multiple paths and I don't have to worry about network issues affecting my VMs. VMware's vSphere leverages NVMe offloads like extended copy or zero write. So those things are offloaded automatically. We'll be releasing a CSI driver for Kubernetes and a Cinder driver for OpenStack about a month after we release the new version of the software, since that testing has to be performed with production level code. So we're targeting this block at customers with large numbers of VM hosts like cloud and hosting providers. If you have 1,000 hosted VMs running Linux in your environment, that means you have 1,000 copies of Linux. And VAST's ability to have very large data sets that are a single data reduction domain makes that cost effective for those cloud providers. These customers are frequently running open source Ceph and discovering that it doesn't provide the performance or scalability that they need to move forward, especially as their customers start to be more demanding about performance. The second major update is the addition of an event broker. Event-driven architectures are basically what we mean when we say cloud native, that an event broker facilitates reliable and persistent message passing between services or microservices. So if you have a workflow where a task is performed by one service and then the result of that is processed by another service, an event broker is how the first service tells the second service it's done and it's your turn to move along. The most common event broker is Apache Kafka. Kafka is an open source project written in Java. It uses a cluster of brokers, as you see on the screen. Each of those brokers uses local storage, and Kafka cluster managers have to decide how many replicas they're going to have for resilience, how they're going to partition topics across the brokers. Load balancing is a manual process, and it all becomes quite complicated at scale. But the critical part, what really is the core of the event brokerage, is that producers, those boxes at the top, servers that are writing in and sending messages, publish entries in what are called topics. And a topic is a sorted list of entries. Consumers read off of a topic, and they read entries out of the topic in order. So the message passing from task A to task B saying it's your turn to work on this data, which would include things like the URL of the data to be moved on, gets written by task A as a producer into task B's input topic. Task B as a consumer reads that off and says, oh, this is the next piece of work I have to do, and does it. There are a lot of moving parts to manage to do this in Kafka, and so we've decided to make it simpler by implementing an event broker as part of the vast data platform. The difference between a protocol and an API is a matter of perspective. If you're a programmer, it's an API and you have a piece of code you're supposed to call. But if you look at at a standard set of messages being passed across a network, then that API defines a protocol. And that's how we view the Kafka producer and consumer APIs. So we've implemented Kafka as a protocol module, just like file and block and object. Messages come into a set of C nodes that are paying attention to a VIP that act as a broker cluster. When entries arrive via the producer API, they're written directly to tables in the vast database. And when they're consumed, they're read out of those tables. That means, in addition to simply providing the resilient, persistent message handling, the vast event broker also allows you to do real-time analysis and see what's going on in the path between task A and task B by querying that database table directly. Doing that in Kafka requires building an external database, providing connectors. Those connectors only run periodically to export topics into the database, and you don't really get real time. Like everything else in the vast data platform, you get all the functionality you're looking for, 100% API compatibility, and it just works. So we implement NVMe over TCP and Kafka as protocols because that allows us to provide the high degree of performance we do through all of our protocols. It allows us to provision things like Kafka topics simply as databases, to provision a volume within a folder so that we can apply the same set of data services to these new data types that we apply to files and objects. In the security and multi-tenancy arena, we're adding HashiCorp and Fornetics to the previous support for Talus enterprise key managers. We've extended multi-tenancy to include the vast database. We're extending multi-tenancy from simply the data plane to the management plane of the vast data platform. And we'll get to that in a minute. And we're adding AWS style token authentication to API calls for cloud providers who don't want to be using more traditional login authentication to access those features of the system. Oh, that wasn't the slide I was expecting. So let's just do this. As I mentioned earlier, in the HPC and AI worlds, much of workflow automation is performed by schedulers. And that means that we don't have things like user IDs that separate what we would call noisy neighbors from each other. We are releasing a open source vast collector that uses the extended Berkeley packet filter interface on Linux clients, which is very lightweight, to collect data about which I/O is being performed by clients, and to add it to, now I've lost the word, to add to that metadata environment variables determined by you, the system administrator, which would typically include things like the job ID from the job scheduler. This data, it can be written to local JSON files for you to analyze it however you like, or to a vast database table so that you can do analysis to find who was that noisy neighbor, what was this job that promised to be well behaved that wasn't. And since this is an open source project that's collecting data at the client, if you're writing to local JSON files, it will work regardless of what the NFS target is that you're accessing. So you can use this to generate that data with other people's storage too. Jason, you're up.
All right, I'll come on stage here. There are a couple of advances in the database space. I think Howard already intimated some of the more important ones, but we'll go over them again here in a little bit. So we have some database performance enhancements, and I think the most significant one is table defragmentation. So a database table in VAST is very similar to the presentation layers S3, NFS, and that all the data is housed in a shallow B tree structure that's similar to everything else in VAST. As databases are updated and changes happen to it, things get inserted and pulled in and out of that tree and need to be dealt with. And so we have some improved defragmentation mechanisms that are essentially scrubbing jobs that go through and keep that table optimized. VAST database is an analytical database first. That's what it's really good at, but it is also transactional. So we have to be able to accommodate very minor changes to the database on a distributed system. So we now have the ability to optimize those tables and keep them running fast, regardless of the types of small IOs that are happening on it. My favorite thing on this slide is the improved data ingestion. Facilitate smoother data ingestion and processes, supporting scalability, blah, 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 blah. Well, that's what Mark was just talking about for half of his presentation. So I like understatement, and so this is pretty understated. We have the ability to ingest data into the database tables directly over Kafka APIs. This is a really, really big deal. It's probably the most important addition to the VAST protocol stack in a couple of years. It is significant today because we can ingest data into the database and then immediately act on it before it's even consumed by another consumer. But it's also part of VAST's future in terms of the features and capabilities we're talking about going ahead. So this is a very important feature. It is very fast. It is a C++ implementation of the Kafka APIs, not Java or not just a repackaging of anything open source. So very high concurrency, very high speed. We also have the ability to, well, on the next slide, we have a bunch of improved visibility. So this is a little bit of catch up actually. The analytics tools on VAST didn't have as complete of a list of visibility tools, and we have now caught up in 5.3. We can now look at database traffic that's going to and from tables. Just to recap a little bit, database traffic is a protocol. It is an API. So when you're talking to VAST and you're talking to a database table, you're talking over an API. It is a parallel distributed API that is designed for working with parallel processing engines. So we're talking engines that talk to the entire set of vast hardware at once, or can, and in a single transaction, or a single query or action or filter. So now we have the ability to go into our data flow system and see that traffic happening, and which can be very high throughput. So this visibility is very nice. Even more importantly than that, we have the ability to monitor IOPS, amount of operations per second that are happening on a table, the amount of rows, which is not the same as the amount of IOPS, and latency performance. So all of this is now user friendly, and in the database. That's actually it for the database improvements, and I think we will hand it back over to whoever we're handing it back over to.
Thanks, Jason. Yeah, that basically brings us to the end of our prepared slides for today. So I did see one question in the questions area, which asked about, what the visibility of table type elements was in the vast data store. So tables as elements are stored in folders, and you can list a folder that contains tables, but you can't just open a table element via NFS or S3.
Yeah, you're not going to interact with it like it's a Parquet file or something like that. It's not exposable. You can see it. You can even do mean things to it if you really, really want to. But no.
From the useful point of view, you can see how big it is.
Yep.
Awesome. Thank you so much, Howard and Jason. I appreciate you all coming on here and presenting. If anybody else has any questions, feel free to throw them in the Q&A chat and we will follow up with you after. You can also email us at hello@vastdata.com. And if you want to learn more about VAST, you can join our community, or you can join our weekly live demos. They're every Tuesday or Thursday. Just go to vastdata.com/demo. We appreciate all of you for being here today, and we will talk to you very soon. Thank you, everyone.